All right, so this video is an introduction to the oscilloscope. In this video, I want to go over what the oscilloscope is, how it works, how to control it, and how to get accurate measurements from it. One of the things that I think makes electronics a little bit more challenging for people is that it's not very sense-based. Like the electronics is, you can't, for example, if we take this board, it's got a bunch of lights, got clicky switches and push buttons and little displays, but you can't actually see how the signal is propagating. You can see if the LED turns on, but if I have a high frequency signal going to the LED, you can't really tell. So whereas mechanical engineering, for example, there's, has a bunch of gears moving, it's very machine-based, there's a lot of moving parts, it makes sense, it's very concrete in how it works. You can see if it's working or you can see if it's not. And often you can diagnose what's wrong with it just with your senses. Whereas electronics, that doesn't quite work as well. If you're actually sensing the electricity, it might be a little too high voltage and I would walk away slowly. So with electronics, we need instruments to actually connect to and see the signals. And the oscilloscope is one of the most important instruments that you'll use in electronics. Fundamentally, all it does is measure voltage over time. So voltage is going to be your vertical scale and the horizontal will be time. Now the oscilloscope is going to be used primarily for high frequency. It's going to be used for small time periods. What you wouldn't use the oscilloscope for is measuring something that changes over a long period of time. For example, you wouldn't use the oscilloscope to measure a discharge of a battery over a couple of days or a few hours. For something like that, you would use perhaps a data logger or some other piece of instrument. Another thing that the oscilloscope excels at is gathering small pulses of data or things that are not recurring waveforms. They're not repeating waveforms. That, for example, an I²C, the data bus is normally whatever your VCC is, either 5 volts or 3.3. And when it sends data, it's going to send it over in short packets. So it's a non-repeating waveform. And we can use the oscilloscope to gather that small piece of, that brief packet of information, and then we can examine it, we can look at it, and measure it. Now this video is going to be primarily just an overview. We're going to look at the very basics of operating it, but future videos are going to get more in depth on various aspects of it. So like I said, fundamentally, the oscilloscope measures voltage in the vertical scale against time, which is the horizontal scale. Now, right now I've got off screen, I'm just using a coaxial cable, which is right here. I have it connected directly from a function generator, and I'm using one of these pass-through terminations. So the source of the function generator is 50 ohms. So this is also a 50 ohm termination, but it will pass the signal through. So that way what is being sent from the function generator is actually what we see. And I'll have another video a little bit more in depth on that as well. Now, if you're using your own oscilloscope and you know what you were doing last time, you probably can skip this step. But in labs, I always recommend for students when they first come in, they obviously turn it on like it is that you hit this default. So a lot of times the people before will have all kinds of various settings that the oscilloscope will retain. And so when you go to plug it in, it looks like it does all kinds of weird stuff. So I always recommend you press the default setup. All it does, it just obviously sets it to a default. So we'll just click that. So you can always undo the default. So if you accidentally hit that, you can just go back and it's basically an undo button. So just click that. So now it looks like there isn't any information, but we can see the time scale is 4 microseconds. Before it was, I think, in the milliseconds. I'm only passing a 25 hertz sine wave to it. So this is, you can see there's a little bit of a vertical scale to it. So I want to change the vertical scale. Now, if you've noticed, there's a bunch of white dotted lines that are kind of in the background, that this is the graticules. So this basically breaks up the entire screen into equally divided segments. So in the horizontal, it's 10 divisions. In the vertical, it's 8. And then down here, this will tell us that the vertical, which is over here, is 1 volt per division. So I can put 8 volts from top to bottom on this scale. So the horizontal scale is 4 microseconds. So if I've got 10, it means from this side to that side is only 40 microseconds. So I have a 25 hertz signal going in, so this is far too small. So in order to adjust the horizontal scale, I'll go over to the horizontal section of the oscilloscope, and we'll increase the amount of time. You can see we're actually starting to see some slope. Now I can see the most of the sine wave. So clearly my 1 volts is not entirely accurate. The problem is that I'm using just a coax cable. So the default setting, so if I want to go into the channel 1, so right here this is the vertical section, so these knobs and this button controls channel 1, this controls channel 2, and there are other models in this particular series that will have a 3rd and 4th channel, but this model does not have it. So I want to change, so this is just a coax cable. I don't want this probe setup to be 10x. I actually want to change that to 1x. So you would use the 10x if we were using the 10x probe. So the 10x, I'll get into this in another video, has to do with the attenuation. It has to do much more with the scope probe and the bandwidth of the scope probe. But for this, since this is just a coax cable with a terminator, I want to do 1x. So now it hasn't changed the size, but it has changed the scale. So I'm now at 100 millivolts per division, and I want more. So there we go. So you can, one of the things about this knob is that its default is that it goes from like 200 millivolts to 500 millivolts. So if you want to see more of this wave, you can actually just press the number 1 to bring up this menu. So these are the soft keys, and press this more button. And so now I can change the scale a little bit more finely. And so for that, I use the multi-purpose knobs, and they are called multi-purpose for, you guessed it, because there's more than one purpose for them. So I'm going to, actually I want to increase or decrease the scale so I can see more of the wave. Let's change that to 300. Now, if you if you want to go from 300 to 500 more quickly, you can deselect the fine button, and then it will change more rapidly. Basically, just save a little bit of time. So we'll just go back to 300, and we'll click menu off twice, so we can see as much as we can. So now I've changed the function generator frequency to 250 hertz, and now it's showing far more waves, far more periods. So in order, I want to actually be able to see just a couple of waveforms here. This is just way too much information on the screen. So I'm going to change the horizontal scale from 10 milliseconds to smaller. So I'm going to decrease this. And there we go. So I'm now down to 1 millisecond per division. So that means from this side to that side is 10 times my time per division. So this is 10 milliseconds from one period, from one side of the screen to the other, and 300 millivolts. And it's 8. So that's, see if I can do the math, that's 2.4 volts from the bottom of the screen to the top of the screen. Okay, so one more thing I forgot when I originally shot this video was to show you the in the vertical that you can change, that you can move where on the screen that the waveform is displayed. And so that's just as simple as moving that up, moving it down. Now, it doesn't change anything. All the peak to peak and the frequency, all the scales stays the same. All it does, it literally just moves it. So you might want to do this if you have, let's say you have two waves that are just about right on top of each other, and you want to be able to make, you want to show that there is some difference. You can move one channel up, move one channel down, and also with the horizontal scale, you can move it left and right. Let's say, for example, all right, so let's say I want to measure a square wave. So we'll just move this down. and we'll line it up. All right. Also, there's in the horizontal, you can change the position of the trigger point. So you can see right up here in the screen, there's a T, and it points the arrow. So this is the point. So this is your time equals 0. So this is the whatever you set your trigger level at, that's where it starts. So we can actually move this left and right. So one of the reasons that you might want to do that is, let's say I want to really decrease my time scale to the point where I measure the rise time of this function generator. So one of the reasons I might want to shift this over to the left is that, for example, this screen is blocking some useful information, or since this is my trigger point, I actually want to see more of the waveform. So we can just, so I've zoomed my scale in. Now I can, if you look up here, this T, this actually points to, on the horizontal scale, where your trigger point starts. So this is, think of this as the time 0. So over here is positive time, over here is negative time. Now, if I want to, for example, I want to measure the rise time of the square waveform of this function generator, I can bring the cursors. No, it already was up. Another thing that is useful to know is that you can also look up here. That tells you that the cursors are off screen. Now you can just quickly bring that and press that button, and that will bring the cursors onto the screen. A lot of times, if you press the cursors button, you don't know where they are. That's just a quick way of doing it. Instead of looking up here and then turning the knob until you get there. All right, so I would use the cursors to, we're just gonna guesstimate where the rise time would start and end. And we'll just select, we'll move this guy over, and so I'm just lining that up. So here, measure the change in time between that, and it's 24.8 nanoseconds, and we can just estimate, and that's what my rise time is. So if I had if this was centered, it would be a little bit more difficult to see where roughly this is. The minus 3 dB actually might be a little bit lower. That'd be a way to measure the rise time manually. Of course, we can always just go into add measurement, and let's just do rise time, add OK. So we're actually not too far off from what it's measuring. So this looks like hovering around 23 nanoseconds. So not too bad for ballparking it. So another thing I want to mention just briefly is that you can see this center graticule and this center graticule. This is kind of your, we can move that. So the center graticule, think of it as the time equals 0. So you can think of this as kind of like negative time, and this is positive time. So that's only time with reference to the trigger. So the trigger section on the oscilloscope is over here. All we need to do is adjust that, and you can see a yellow horizontal line appears, and it seems like I'm moving the waveform back and forth, but what I'm doing is setting the trigger level. And you can also look down here that it will change. So I can set it to a specific voltage. So let's just say, since it's 300 millivolts per division, it's going to be a little math. It's going to be funny. But basically, all it is it's telling the oscilloscope where to start measuring. So I've set the trigger level at 0 volts, and now the 0 volts lines up with the time equals 0 here, and the waveform essentially starts at this point. Now, one of the things about the trigger is that you might turn it on, and it's doing all kinds of fun things like that. So the reason this is doing that is because you don't have the trigger set. So you can look at down here and be like, oh, it's 1.26 volts is my trigger level, and I've got 300 millivolts per division, and it's like, oh, I'm above this, so I'm off the screen. And when that happens, just move your trigger level, bring it down, and we'll keep it at 0. All right, so that is the basic parts of an oscilloscope. We're going to get a little bit more in depth into all of these other sections. So just real quickly, let's take a quick tour. So down here, this is a lot of the kind of not necessarily the functioning or the manipulating of the waveform on the screen or the view of it. This has to do with operating the oscilloscope. You can save the images, you can save the waveforms. Obviously, the default setup will just take everything to default, so any settings beforehand will just get wiped out. This particular oscilloscope also does, it's a mixed signal oscilloscope, which means it can do digital as well as analog, and actually can display it simultaneously. Right above the trigger level, we have a run stop and a single, and this is called the auto set. Auto set is what I call the cheater button, and so we're going to just pretend for now that doesn't exist. You can use it. I've found often it doesn't work. So if you don't actually know how to manipulate the view of the waveform and you just rely on the auto set, a lot of times it won't work, and then you're going to be stuck anyway. So you might as well just learn how to do all of this stuff manually before you just do the lazy thing and hit the auto set button. But the run stop will have to do with the display. Single button will be used for capturing single triggered events. This wave inspector is very useful for if you want to capture a longer period of time, but you want to then inspect and go into greater depth. So for example, with your I2C, maybe the packet is a lot longer than what you could reasonably display, and if you display the whole thing, you wouldn't be able to get as much information off of it. So this has a lot to do with the inspection, and again, the cursors, that goes with manual measuring intensity, so we can change the intensity of the various things. So for the example, the waveform, the default is 35. Actually, I meant to turn that up to 65. And then graticules, we're going to change that. Well, see, I'm going to go to fine, and I want to change that down to, I think, about 50. So a lot of this has to do with just making it so it's a little bit more visible, adjusting to your personal preferences. Cursors, we'll get into a little bit more manual measurements, and the measure button, one of the things that's very nice about digital oscilloscopes is that it can do a lot of these measurements automatically. We'll see in another video that that's not necessarily going to be always accurate or helpful, so you still want to be able to do the cursors or just read the information from the time scales and the horizontal and vertical scales, and just actually get it by inspection. All right, that's the end of this video. For future videos, I'm going to be getting a lot more into depth of the measurements using the graticules, the cursors. We're going to get into saving images, waveforms, and a little bit more in depth of many aspects of this oscilloscope. All right, I'll see you in the next video.